Thunder and lightning are the most commonplace effects of electricity seen in nature. Primitive peoples thought they were a sign of the anger of the gods. Sometimes sailors at night would see a strange light in the rigging, which they called St. Elmo's fire. And people in the north saw the northern lights, or aurora borealis. With so little to go on, it's not surprising that for a long time, men knew next to nothing about electricity. It was a Greek philosopher called Thales, who in the 6th century BC made the first electrical experiment. For hundreds of years, man learned very little more about electricity. Then, early in the 18th century, a Frenchman named Dufay came to the conclusion that there were two sorts of electricity. Soon after this, Benjamin Franklin proved by a dangerous experiment that lightning was electrical.
Today, whether the generating station is to supply a manufacturing town, housing estate, or a rural area, we must first plan where the cables will be laid and determine the course of the main arteries which are to carry electric power to the members of the community.
And here they are, laying one of the ever-growing networks of cables and wires which travel beneath the streets of the fields and sometimes beneath the waters of rivers, bringing heat, light, power and communications to every house, office, factory, theatre, cinema, farm and village. What romance lies there in those tunnels underneath the streets on which we walk? Cables like this are being laid all day, every day. A cable like this, no thicker than a man's wrist, is capable of harnessing 140,000 horsepower. Power for business, education, light for shops and homes, power for factories, power for transport and communications, power in fact to benefit all in health, work and play.
Instead, we may have shuttles traveling by levitation above a superconductor road and without gasoline. 300-mile-per-hour trains suspended above superconductor monorails. Imagine electricity itself traveling so easily through power lines that its cost is reduced by 90%. That is the pie in the not-so-distant sky.
Welcome to Future Human, the series, the podcast where the team here at Silicon Republic explores the future of everything. I'm Anne O'D. In this episode, we're looking at the future of renewable energy and why we need to reimagine our electrical grids. This series is made possible by our presenting sponsor, Hays, that's Hays, is the world-leading expert in recruitment and workforce solutions, specialising in the professional and technical sectors and skills. Thanks to their support, the rest of this episode will be totally ad-free. To access great advice and insights, visit haztechnology.com/blogs. In 2024, almost 1/3 of the electricity here, where we're recording in Ireland, was harvested by wind farms. We also increased our onshore wind capacity to 5,000 megawatts, bringing us closer to the Climate Action Plan target of 9,000 megawatts by 2030, which is great, but only part of the story. In 2024, we also lost more wind energy than any other year. And that's because our grid can't always handle the amount of energy being generated. And so wind farms risk being shut down and we miss our opportunity to turn all that wind into power. And it's a problem that is far from unique to this island. The transition to renewables is not just about installing more solar panels or more wind turbines. It's about rethinking and redesigning our entire energy infrastructure, including our grid. It's about building a secure energy system that can handle the electricity being generated by wind and solar farms. And it's also about planning for those times when, say, the wind isn't blowing, and developing new storage technologies that can keep that energy until we need it. In short, we need to increase the capacity and flexibility of our energy systems, and that is a global effort and will require global collaboration. To get that global picture of where we are in the energy transition to net zero, Jenny Darmody spoke with Franziska Weiss, VP of Market and Business Development in Europe for Siemens Energy.
Can you tell me a little bit in your own words how you see the current state of the global energy landscape? So what we see in nowadays in the global energy landscape is actually really a changing system, right? Maybe responsible now for Europe. I can see that even in Europe, where we have, let's say, common targets and in even a plan of that, we have different starting points and really different elements coming into play. And if you put that in a global perspective, you have even more, let's say, changing factors. So the energy landscape is definitely ever changing.
And what are the key factors, do you think, that are contributing to the energy crisis that's currently going on?
From my point of view, when you look into the energy crisis, you see after the invasion of Russia to the Ukraine that energy is not longer a commodity. Would you see that the reliability on energy security developed into actually a political security as well? So the nations relying on, let's say, one-sided import of gas and the dependencies thereof, and then the changing system needs in establishing, let's say, a more self-reliant, renewable-based energy supply is definitely a changing factor that we see. And the other impact that we can observe is definitely the impact of climate change. So in almost every country we see, looking in Europe again, we're experiencing very hot summers with wildfires and droughts, while we have wetter winters. And this unpredictable conditions in the weather is also impacting the energy mix. So it requires really an energy mix that is affordable, reliable, and sustainable to combat that.
So the climate crisis affects all of humanity, and the shift from fossil fuels and towards renewables is a global effort. But every geography is different, every country is different. We wanted to get a sense of where Ireland is in its energy transition, so Jenny spoke with Barry Hayes, Senior Lecturer in Power Systems Engineering at University College Cork.
Our research focuses on electrical power systems, or in other words, electricity grids. I lead a team of PhDs and postdocs here at UCC, and we study the planning and operation of future electricity grids and net zero energy systems. So this involves coming up with new tools and methods that can help us better integrate renewable energy into the electricity grid and make better decisions around how we plan the electricity networks and how we manage them in real time. I also teach electrical power systems to undergrads and postgrads here in UCC, and I also do some work as an advisor to energy communities around Ireland. So I give them technical advice on developing community-owned renewable energy projects, on project development and getting grid connections and so on.
And what do you see as sort of the biggest challenges that kind of come with connecting those large-scale renewable energy projects like wind and solar and things like that to the existing power grids? So
our grid infrastructure just doesn't have the capacity to accommodate all of the renewable energy projects that we want to connect to it. Large parts of our electricity grid, from the high voltage transmission grid down to local distribution networks, they're already overloaded, or in other words, they're trying to cope with the projects that we already have connected. So our grid infrastructure is, in many cases, it's too old and it's too outdated, and the investment in the grid infrastructure hasn't kept pace with the demand for these projects. I would say that this is not just an Irish problem. So the electricity grids in a lot of developed countries are suffering from the same problems. There was a report last year from the International Energy Agency, and they identified electricity grids as the weak link in the energy transition. Their study showed that many countries won't be able to achieve their renewable energy and their decarbonisation targets because the grids needed to support this just aren't ready. Another big issue, which is very much related, is the planning process. So we struggle to deliver these projects even when we have the money and the political will, just because of the uncertainties around planning, the delays in getting planning permission. So NIMBYism is really holding back the transition to clean energy, and I think that's something that we need to confront if we want to make this happen.
And are any of these challenges things that, are they challenges that couldn't really be helped and these are the challenges that we just have to deal with now? Or are some of these things that maybe should have been started to be fixed earlier? I certainly think the planning, just as you say, NIMBYism, I wonder, is that something that should have been started to fix earlier than now?
Yeah, look, possibly. I mean, to be fair to, the likes of Onboard Planola, the legal system in our country favours objectors. It's not for me to say whether people have valid objections or not, but it's just the time that it takes that creates too much uncertainty for developers, and projects just lose momentum and don't happen. And again, I think it's related to planning also, but the ambition in developing our energy infrastructure and the grid in particular, we certainly, we've underinvested over the years, and we could have prepared better, I think, to keep pace with the demand for grid connections.
The electrical grid is a complex network of power plants and substations, transmission lines and distribution networks, all to produce electricity and deliver it to homes and businesses. The grids that most of us are working with were designed for the flow of electricity from centralised power plants to consumers. But as we integrate renewables, we need a grid that's more dynamic. Renewable energy sources are often decentralised. Take Ireland, for example. We have almost 400 wind farms scattered around the island, so we need a grid that is smarter and more flexible. We're going back to Jenny's conversation with Francisca to understand the role of a reimagined electrical grid in a new green economy.
And, in that sustainability space and the kind of current over-reliance on the fossil fuels and everything like that as well, what strategies and technologies do you see being kind of crucial towards that transition towards more sustainable energy sources?
So when I look from my view and working in Siemens Energy as a global player in the energy field, I would say that we have the electricity grids playing really a major role in the transition. They are, in Europe's perspective, really the backbone of our green economy. And we will also continue to consume more electrical energy over the years. So we have today around 23%. And when we look into the electrical consumption, it will increase up to 50% at 2050. So I don't think we always talk enough about really the necessity of the grids, but that is definitely a very important part. We need to have more of them, and we need to have a speed in bringing them up. And that would bring me to my next point. So I think we need to find a way to have more of a standardized approach in how we are designing projects. We have not achieved that yet to actually really support scaling up the production and the increase in capacity. So that is definitely an element that we need to consider in designing and defining the specification of projects. And another element would be the cross-border energy sharing. So we need to maximize the use of clean and green energy. And when we look into current examples, one is, for example, the Viking Link connecting since December last year, the UK and Denmark, which is really a great example in how we can support the growth of renewable energy by connecting countries, supporting the intermittent, but also the exchange between the countries there. So that is definitely also a point, and it's also a target in the European Union to actually enhance the cross-border connections.
And do you think, you mentioned about the energy grid and the electricity and the strain that's going to be on it. Do you think sometimes there's almost an oversimplification of, moving to renewable energy, like where we all talk about we have to move to these energy sources, but without really addressing those challenges that, the infrastructure is not necessarily there yet?
Yeah, so I think, that the challenges are as mentioned, multidimensional, right? You have the growing demand, and with that, you have the demand of more capacity installed. And you also have the challenge of how can we actually use existing assets to the maximum, right? the danger of stranded assets, so to say, should be minimized. So this is also a way of supporting the sustainability. And we should not forget, when we look at it globally, right, that the demand for us will increase. And if we have, let's say, some countries more advanced in their target towards net zero, other countries in part of the world might still work on getting electricity even outroad to their peak, right? And this complexity is definitely impacting the situation.
And what kind of advancements do you think are necessary for modernising that energy grid, to make it more able to manage, I suppose, the supply that's coming down the track? What kind of infrastructure technology needs to be put in place to modernise that energy grid?
I tried to mention that already before, right? We have also a kind of a complexity when we look into the grid infrastructure, not only on a country level, but really more on a European or on a global level. Considering the European, we have 27 national grid codes in Europe. And that means that technology that, for example, we produce in Siemens Energy has to comply with 27 different grid codes. And that is definitely not supporting the speed or simplification in that regard, right? And also picking up on the project design aspect. So we see projects that have thousands and thousands and thousands of pages of specification. If we are not able to take there a certain level of standardization, supporting the scaling up of projects, that will definitely impact how the grid infrastructure will develop over the years.
And is there anything that governments or regulatory bodies can do to help foster a more sustainable energy sector? Or is there anything that bodies and governments are doing already that is supporting it better than maybe others?
I would say to manage the energy transition, there is really the multiple technology aspect we have to bring into place, right? And it needs to support the affordability, the reliability, and the sustainability part of it. And I would say that policymakers and industry must collaborate to ensure that sustainable technology mix. So when we look into measures to be taken, and when we look into some data, we see that 45% of all of the emission savings that should be applied by 2050 is coming out of technology that is not even yet in the market. So we need to have an environment that supports bringing that technology into the market. That's definitely an aspect. The other aspect is around the supply chain. So when we look into robustness and reliability and resilience of supply chain, that is definitely important, and it will also support the predictability. So when we consider the growing demand and the growing capacity, this needs to be manufactured, right? For example, so projects developed. So you also need a predictability on the timing, but also on the scoping, so that we can actually speed up on the project side as well. And another aspect that could be mentioned is definitely when you look into newer technologies, we still have cost very often as a decisive factor. But when you apply new technology, lowest price first is not always, let's say, the supporting factor in bringing these to a successful market implementation.
Like Franziska said, this isn't just about generating energy, but about storing it. As we increase the proportion of energy that comes from renewables like solar or wind, where activity fluctuates, we'll need a better energy storage infrastructure to cover us during times of low activity and energy production. These long-duration energy storage technologies are systems that can hold energy for longer than 10 hours. Batteries are the obvious choice here, but 10 hours is a stretch for most of our current technologies. And there are other challenges. The resources needed to make these batteries are finite. Mining them can have a negative impact on the environment, and they can be subject to geopolitics and supply chain bottlenecks. To dive a bit deeper into the potential and challenges of battery storage, I spoke with Johan Soderbaum, thematic leader for energy storage at InnoEnergy.
If we are looking at the situation we have in Europe right now, but I would say that it's global. I mean, we have a challenge where we are making a transition to some sort of a sustainable energy system. So, and in that respect, we are doing quite well, I would say, on a European basis. I would say that we are very, very good at addressing the Paris Agreement with Fit for 55 and all these policies that we have taken in Europe. And the result of that is that we have an enormous pace when it comes to introducing renewables into the system. And we have a super high pace also when it comes to reshaping the consumption that we have. We're rapidly moving away from gas, for example, in Europe. But the consequence of that is, of course, that we need to add wind or solar, for example, to the system. And we are changing the way we are using electricity. So all of this is really quite stressful for the grid that we have in Europe. And that's where, for example, batteries come or energy storage comes into play. That's a really excellent flexibility measure that we can add to the system.
So tell me then how storage and batteries can be the faster solution.
What we have seen the latest 5 years is that the batteries on a massive scale is being deployed in the grid. So contrary to what's actually believed, the batteries that you deploy is not really to even out the variations in solar or wind. It's to handle losses from nuclear power plants, for example, because the batteries that we deploy have limited storage capacity. But we also see that since batteries are becoming cheaper and cheaper, we also see that we are moving into the regime where you actually have longer storage capacities deployed. So you can actually also handle the variations in energy generation from solar and wind. So
do we, I suppose we probably have the technologies, do we have the resources given this rapid requirement and rapid growth in the requirement for storage and batteries?
Yeah, that's a good question. Looking at it from a global perspective, we seem to have that because there's no shortage of battery cells or battery systems. But from a environmental and ethical perspective, then some of these supply chains might be a little bit questionable. And looking at it from a European perspective, we don't have anything. So that is definitely something that needs to be addressed. One of the biggest industries in Europe, that's the automotive industry. And Europe is producing about 30% of the vehicles in the world. In 2017, it was thought that, maybe it's necessary then to have some sort of a European value chain for batteries so we can at least supply these 30% of global vehicles that are being built in Europe. That's when things started to happen in Europe to actually set up this value chain. So looking back now then, I mean, we're in a completely different situation. We have the IRA in US that has completely overpowered what we've been doing in Europe. And we see a massive overproduction, for example, of fairly inexpensive battery cells in China.
And tell me, all these batteries being created, like what can be done to ensure that they're, if not reused, recycled?
It is a very, very interesting part of the story, actually, because when we discuss about recycling and circular economy, we generally have some sort of vision that when the car is used up or you crash it or anything like that, then you pick out the batteries and you recycle them the way we do with the batteries from our phones or whatever it is. That's not the case, actually. Hopefully that will be the case. But this is way much more urgent because as soon as you push the button to start manufacturing battery cells, what you get is a massive amount of scrap out of the production. And even if you have a very efficient and good yield in the production, you still generate massive amount of scrap from that. And that's, when I say scrap, it's not really scrap because it's super valuable metals and materials that's coming out of that. So it's all this, nickel, manganese, and cobalt, and all that stuff that goes into the cathode, and graphite, which we don't have whatsoever in Europe. So all of that is valuable material.
What kind of progress are we making on industrial level storage?
to support the grid?
The technology for deploying stationary storage, it's not that complex. That's something that we know how to do quite well. But the real challenge here is when you are moving away from what we talked about earlier, which is frequency support, to actually being able to store excess energy from wind, for example, just over the day is quite challenging. There's a term called long-duration energy storage, and that's today a little bit vaguely defined, but as 6 hour plus. And then it's becomes very large footprints and quite expensive if you're going to use the classical lithium-ion batteries. In this case, you are definitely looking at different technologies, not just different chemistries. Again, as I think I started out with, there are way other means of flexibility to add to the system. We have connectivity, we have understanding of processes in a completely different way, which makes this, I shouldn't say for free, but it's already there in many cases.
Johan highlighted the importance of connectivity, something that presents unique challenges for an island-based system like that in Ireland. Connectivity was something that came up in Jenny's conversation with Barry too.
What I'm more excited about is where we go next with grid interconnectors. So these are undersea cables that connect us into other countries. With 2 undersea interconnectors to the UK. We're building another one to Wales, which I think is going to be energised next year. And there's another one we're building to France. And that's a real game changer because we'll be connected directly into the main continental European grid for the first time. And we need to look at where we go next with that. So do we try and interconnect with the likes of Netherlands or Belgium or Spain or even further afield? So there's some researchers are looking at this idea of really long distance interconnection. So interconnectors running across whole continents or even a global interconnected grid. And this could solve the problem of what do we do when the wind doesn't blow or the sun doesn't shine. So if you interconnect grids over a large enough area, it'll be windy or sunny somewhere, and maybe you don't need as much energy storage.
So connectivity is important. Like we said, this is a global challenge, but we also need to consider the decentralised nature of a green energy system. After all, in Ireland, for example, energy will be generated at wind and solar farms all over the country, and this presents a fascinating opportunity. Back to Jenny's chat with Barry.
With the rise of sort of those energy communities and distributed energy resources that you mentioned, how do you see the role of decentralised power systems kind of evolving over time?
The energy community model is a really interesting one. It's all about giving individuals and communities more ownership and more decision-making power around how their energy is produced and used. This idea of community ownership of energy, it's really taken off in countries like Denmark and Germany, and it's growing here in Ireland. They already have more than 800 registered energy communities in Ireland. And I work with some of these energy communities. Often they'll have a piece of land in the local area, and the community wants to develop a renewable energy project on it and share the profits generated from that project back into the community. On decentralised power systems, the electricity system is naturally becoming more decentralised because we're not generating as much of our electricity from the traditional big power plants that usually ran on fossil fuels. We're generating a lot more of our electricity now from wind farms that are connected to remote parts of the grid, from solar panels on people's roofs. So in the past, the grid operator, they only had to manage a few dozen power plants, and they could control those or dispatch those according to the electricity demand on the system. Whereas now we're in a situation where we've thousands of generators connected to the grid. We've thousands of new injection points. And on the demand side, it's changing as well, as we try and electrify transport and heating. So we're evolving away from a very centralised approach to managing the system towards a more complex, a more distributed system, and one where we have a combination of centralised and decentralised controls.
And then finally, how do you think that a collaboration can sort of happen between governments or industry and researchers? Like, there's a lot of different moving parts and people involved, but to make sure that policy and the technology and things like keeps up with the pace of change that's happening with these power systems?
Yeah, well, I think you mentioned people there, and I think that's a huge challenge for the industry. I think we need to look at our policies for higher education and training the next generation of engineers and technical experts. It's very unclear who is going to design and build all this new energy infrastructure that we need. The industry is crying out for more engineers and more qualified technicians, and teaching engineering properly, preparing our students for the modern energy industry. It needs investment in equipment, in facilities, but the government it's been underinvesting in higher education. The amount the government invests in our third level students is decreasing year on year. So I think that investing in training our next generation of engineers and scientists and technicians, that needs to be a priority. On research and innovation, again, we just don't invest enough in Ireland. We've some great researchers and some great startup companies, but we don't have enough of them. If you look at research spending as a percentage of GDP, we spend less than half the amount of countries like Denmark, Germany, Sweden. I think Denmark are a really good comparison for us. We often try to compare ourselves against the UK, but I like comparing us against Denmark. Similar population, similar GDP, fellow EU member. Denmark saw what was coming in terms of renewable energy 40 years ago, and they invested in it, and now they export renewable energy technology to the rest of the world. And why can't we do this? I think we can, but we need a long-term ambition, and we need to fund it properly.
Interesting that the last episode in this season of Future Human deals with energy, because the technologies are complex and the geopolitics are even more complex. But the future of energy will be shaped in many ways by small communities working together to create local energy security. It will be shaped by the creativity of our scientists and engineers who come up with new ways to make our energy systems more flexible. And it will be shaped by us in our choices, who we vote for and what we care about. The future, as ever, is human. This series is curated by the Silicon Republic team and produced by Sean and Morris. The interviews were conducted by myself and Silicon Republic editor Jenny Darmody. The podcast is part of Future Human on Silicon Republic, and for more great content, from filmed fireside chats to deep dive articles, visit siliconrepublic.com future-human. Thanks again to our series sponsor Hayes, the experts in recruitment and workforce solutions.